Hi, this is Irv Shapiro of the Dr. Vax channel. And this video is for anyone that agrees with the sentiment that I saw in a cartoon in The New Yorker just this last week. In the cartoon, the puppet maker, the puppet master, is sitting and talking to Pinocchio, who's sitting on a bench. And he says in the caption to Pinocchio, "I wish you were a real boy so you could show me how to use my phone." Well, for many people, that sentiment rings true about every computer. They struggle with the idea of computers. And I think part of the reason they struggle with computers is they don't understand at all how they work. So in this video, in just a few moments, I'm going to introduce you to how computers work. You're going to learn enough so you actually create your first computer program, which is only a handful of lines long. Very, very easy. You won't need any fancy math or engineering. You're going to learn that computers are really very simple machines. So stay tuned and let's learn something together. Now, if you think this is just going to be a waste of your time, why does anybody need to know how computers work? Let me take a thought from Benjamin Franklin. The thought is that an investment in knowledge pays the best dividends. Something learned today pays you back forever. And today, you're going to learn just enough to make you an informed consumer. Think about it. All around you are computers. Your car has computers in it. Your microwave oven has computers in it, or at least a computer. Your refrigerator often has a computer in it. Your phone is a computer. Computers are all around you. Now, if you knew just a little bit about computers, maybe you'd find them easier to deal with. When you go to take your car into an auto mechanic, if you know just a little bit about how cars work, you're a more informed consumer and you make sure you don't get ripped off. Well, today I'm going to teach you just a little bit about computers. Now, boiled down to its essence, what is a computer? A computer is just a machine. Whether it's a big machine like the computers I first studied in the 1970s, or it's a small machine like this little single board computer that you can buy for, I don't know, 30, 40 bucks. A computer is just a machine. What's special about that machine is it can follow a set of instructions that we as humans, as people, provide it. So most machines, when you put them together, when you assemble them, they work the way you assembled them. But the special part of a computer is with a program, a set of instructions, you customize how it works. So the same personal computer, the same laptop, the same phone can function very differently depending on the instructions it's running at that time, the program it's running at that time. Let's look at the parts that make up a computer. And I've simplified this into sort of a block diagram for you. So in this diagram, the green is the computer, what we think of as a computer. The orange components are inside the computer. They're sort of in the box in your laptop. You start with a central processing unit. That's the brain of the computer. Then you need someplace to store information that brain is working on, that CPU, central processing unit, is working on. That's the memory, often referred to as RAM, random access memory. Then when you're going to turn the computer off, You don't want everything to go away. You want a place to store things for the long term, even when the computer is off. Those used to be called disk drives. Now they're just called storage because disk drives were literally round disks that look like records that were used to store information. Nowadays, that information is often stored on other computer chips, but that's the storage. Let me give you a very simple analogy for this. You're sitting at a desk. You're the CPU. The desktop, the surface in front of you, where you organize the papers you're currently working on, that's your RAM. On your desktop, you can have multiple piles of things, and you can switch between them and work on multiple things. Computers do the same thing. In computers, that's called multitasking or multiprocessing. And in a computer, you can have Excel running in one window. You can have Chrome or a browser in another window. You can have your email program. You can have PowerPoint. On your phone, you can have multiple applications on your phone, all active, one playing music, one showing you a map. That's all in RAM, in memory. But then, when you're ready to go to lunch, the windows open across the way, so you don't want the stuff to blow off your desk, so you put it in a file drawer. That file drawer is your disk drive, your storage, your long-term storage. Sometimes that long-term storage is called an SSD, a solid-state disk. So every computer, whether it's your phone or whether it's this little single-board computer, has all of these components. Then it probably also has a keyboard and a screen and maybe some other things like a mouse you plug into it. So let's look at this single-board computer. This is called a Raspberry Pi. You can buy these for under $50, and it's a complete computer. You could use this like a low-powered PC. So let's look at this in some detail in this next picture. You'll see the chip right in the middle is called the CPU. That's the brain, and it also contains the random access memory, the memory, 512 megabytes. Along the outside, you can see right here, you have various USB ports. That allows you to plug things in, or an Ethernet port to connect to a network. Here you have a port where you can plug in a video monitor. Your keyboard and your mouse would be plugged into the USB port. The long-term storage on this computer is this little chip. That's a micro SD card that plugs in here. So this computer might have 512 megabytes or a gigabyte. A meg is a million, a gig is a billion. Might have 512 million bytes of storage or 1 billion bytes of storage. And this little SD card has 128 gigabytes of storage, 128 billion bytes of storage. So the long-term storage, the file cabinet, generally is much bigger than your desktop. You can put a lot more stuff in the file cabinet than your desktop, which is just like a real desktop. Now, what is a program? A program's just a recipe. It's a set of instructions. If you are good at following recipes, you probably would be a really good programmer. Likewise, if you're really bad at following recipes, don't become a programmer. But it's really quite simple. Let's look at a recipe to make a crepe. I love making crepes. And this is a very simple crepe recipe. You start with 1 cup of flour. You add that into a bowl with 3/4 cup of milk and an egg. And then you mix it in slowly until it's smooth. And you can see how I could write this down on the screen here. Then if the mixture is not the right thickness, let's say the thickness of honey, then you add a little more milk and you keep mixing. That's what's called a loop, where you do things over and over again until you reach a particular condition. In this case, the thickness of honey. Then you heat up a frying pan. You pour 2 tablespoons of this mixture, maybe a little bit more, into the frying pan. You shape the frying pan so it's all leveled out. When the mixture begins to bubble, you take and you flip the crepe over. Then when you see it a little brown around the edges, you take it out of the pan. That's a recipe. It's also a program. Recipes are for humans, programs are for computers. Now, since you can have more than one program in the computer at the same time, you need a manager to arrange how those programs are organized. That's called an operating system. And you might hear of Mac OS or iOS or Windows or Linux. Those are operating systems. And they just manage which of the programs are running at a particular time. Now, programs are written in a language, just like humans, where we speak multiple languages, English, French, German. Computers speak multiple languages. Computer languages in some ways developed like spoken languages. They developed over time among groups of people doing particular things. Some of the names of programming languages that are used a lot today are Java and JavaScript, which are actually two different languages with a similar name, and Python, and C, and C++, and Objective-C. Those are all related languages in that they're similar but not identical. Other languages that if you were in college in the 70s, 80s, or maybe even the 90s you might have heard of were COBOL and Fortran and Pascal. There are lots and lots of computer programming languages. Today, I find, and this statement's going to be very controversial because people get really passionate about what computer language to use for a particular project. But for me, I find that with two computer languages, I can communicate with all of the different types of computers I want to communicate with. One language is called Python, and we're going to learn a little bit of Python today. The other language is called JavaScript. Python is really good for those programs that run off in the cloud. Those are called back-end programs. Those are the programs, let's say, that are running at Google or on Amazon AWS. But then there's also a program running on your computer, on your phone, on your Chromebook that's used to access the program in the cloud. So the program in the cloud is called the backend. The program in the backend is like the trailer on a truck. And the program in the front end is like the cab on the truck. The cab is where you drive, where you instruct it where to go, but the load is stored and refrigerated and controlled in the back end. The front end runs on your desktop computer, on your laptop, on your phone, and the back end runs somewhere else. Python is really good at those back ends. Another language called JavaScript is becoming rather ubiquitous for the front end. And it runs within, very often, it runs within a browser, within Chrome or Edge or Firefox. But it also can run standalone on your device. So between JavaScript and Python, I find I can do most of what I need. Today, we're going to learn just a little bit of Python to show you how easy it is to learn how to write a program. In order to write a program, we need to be able to manipulate stuff. That stuff is called data in a program. And data is somewhere, just like you and I are somewhere. Well, here on the Earth, if you know the precise latitude and longitude of a point, you know exactly where it is. But when I want to go visit John Smith's home, I don't go to his latitude and longitude. I look up John Smith, potentially in a telephone book. I get an address. That address is in words or a name that I can understand as a person. So it might be 8852 North Street or 3537 Blue Street. Same thing applies to computers. Let's look at this slide. So the address, the actual equivalent of longitude and latitude of where things are stored in a computer are in a binary or a hexadecimal address. Binary is where you write out the address in ones and zeros, and hexadecimal is where you write out the address in base 16. It's a number. It might be like FF56EA. That's a number because in base 16, the digits don't stop at 9. But it's just a number. As human beings, it'd be really hard if we're writing these recipes to just have all these numbers. So instead, we give them names. That's like the street address of a home. We call that a variable name. And the actual value, the number 8, or the string of words, this is blue, that value is stored in a variable. Just like John Smith lives at 8852 Blue Street, which is at a particular longitude and latitude. Now, one of the interesting things about programming is use a program to write programs. And that program is like a word processor for program. It's called an Interactive Development Environment, an IDE. I'm going to introduce you to a very simple IDE called MU. MU is a IDE designed for people brand new at programming. But what's really magical about it is I can use it to create programs for my laptop. I can use it to create programs for these single board computers, and it's really, really easy to use. So this is going to be the hardest part of this video. You have to go to a website. It's called codewith.mu. You have to download the program and install it on your computer. Now, if this brings to you the thought of the cartoon I described at the beginning of the video, well, find your grandson or your son or your daughter or your neighbor or your friend or your spouse or your partner and have them help you install MU on your computer. Let me show you what the website looks like now. Here's the MU website. And when you go to Code with MU, you'll see a big download button and a Start Here button. The Start Here button will take you to a whole bunch of tutorials and videos. And what it's showing you right now on the screen is an example of how you might use MU. So all you need to do is click on Download, download the version of MU for your computer, for Windows or for Mac, and install it using the normal installation procedure. Okay, pause the video here and install that program because it's best if you follow along. You don't want to follow along? That's okay. It's still worth watching the rest of this video because you'll get the idea from watching me do it. Now that we have MU installed, I'm going to run MU. So I click on the icon and it opens up. It might take a little time the first time you go to run it. Now, we're not going to need all of this stuff up here. But one thing we do need to do is click on Mode and make sure it's set to Python 3. You'll see there's a whole bunch of modes here. Those are the types of computers that you could write a Python program for using MU. We're going to use basic Python 3, which is what would run on a desktop computer. And click OK. Now, we're going to write our first Python program. I want to display my name on the screen. How do I tell the computer to display my name on the screen, or your phone, or your laptop? Well, I tell it to print my name. Then I start with the parentheses to say, I'm going to give you more information. And I'll say here, my name is John. Just like that. And then I end with the parentheses. Anytime you see a parentheses in a computer programming language, there's always an ending parentheses. Anytime you see something in quotes, it's a string of characters as opposed to a number. When you don't have quote marks, you're dealing with a number, something you can do arithmetic on. When something's in quote, you're dealing with a string, something you can display. Okay, so I just wrote a program. Let me run that program. I'm going to click on this big button here that says run. But before I do that, I'll show you a trick. I can click on this little icon here that says check. And if there was a mistake, it would show me the mistake. So let me get rid of this ending parentheses. Remember I told you have to go together? Click on check. Syntax error. That's computer speak for you made a mistake. Check for missing characters. Yep. Let me check on it again. Now it's working properly. So now let me click on run. So if I'm going to run this program, I have to save it. We'll just call it test. And down here on the bottom, you'll see it printed, my name is John. Let's click on stop. And now let's do something a little bit more sophisticated. Let's create a variable. We'll call it my name. And you'll notice I made the second word capitalized. That's just the convention. You don't have to do that. It makes it easier to read things. The convention in Python is called camel case. It's called camel case because the bumps are in the middle. My name equals John. And now I'm going to say my name is in here plus my name. So this time in the string, I put the first part and then I include a variable. I add it on. Let's see what happens if we say check. No errors. We say run. It says the same thing. Now, how do I know the word John is coming from my variable? Well, when I'm down here in this magic mode with the 3 greater than signs, if I type a variable in, it will tell me what's in it. You see that John is in it. So I can stop now. Now, what if I want to only do something some of the time? Well, then I ask a question. If my name, and use a double equal sign in computer stuff, equals John, and put a colon that says what I'm going to do, I'm going to print my name is John. Okay, well, since my name is John, it should do the same thing. That worked fine. But what if I put Bill in here and say run? Have to stop it first and say run. Stop it, run. It's not printing anything. Why? Because Bill is not John. How do I know what my name is? Well, I can type it down here and you see it's Bill. We just learned the basics of computer programming. You have variables that store things. You have logic that tests things if asked questions. And you do things based on what the result is. Now, we're going to dive right in and create a much more complicated program. If you get lost here, don't get worried, because you might have to watch this a couple times. Now, one of the things you can do with computer programs is you don't have to do all the work yourself. You can use stuff other people do. And those programs that other people created for you, or the collections of programs people created for you in Python, are called modules. So we want to write a program now that's a number guessing program, where it asks you to enter a number between, let's say, 1 and 10. And then if you guess correctly, it'll say you did good for you. And if you guessed wrong, it'll say too bad. Okay, so let's write that program. So the first thing we're going to do is we're going to import. That means we're going to borrow a program that's already written by somebody else called random. Now, I want somebody to guess numbers between 1 and 10. So I'll create a variable called start. I'll say that's equal to 1. And end, I'll say that's equal to 10. Now, if I just went ahead and saved this, and then I said run, then what happened is I got an error. No module named random. Well, because I made a mistake. The shared program is called random with a lowercase r. So let me stop this and run this. Nothing comes out because there's no print statement here. But if I type here start, it's 1. If I type here end, it's 10. Now, I'm going to say the number to guess is equal to random range. And I just knew that. That's something you'd look up in a book or on the internet. And it's a number between start and stop. So what's this going to do is it's going to create a variable called number to guess. And that variable is going to be a number between 1 and 10. Okay, looks complex if you've never seen it before, really pretty easy. Then I'm going to create another variable called my guess is equal. Well, my guess is something I want you to enter in. So, is equal to the input of enter a number So what that's going to do is it's going to print, enter a number, and whatever you enter, it's going to put into my guess. Pretty simple. Now we have to compare them. Well, remember how you ask a question? Well, you just say if. And if number to guess is equal to, now you can't just say my guess. This is a little trick. When you input something, it comes in as one of those things in quotes, a string. A number, like number to guess right here, is an actual number. And you have to compare things that are alike. It'd be like comparing a cow and a dog. Are they the same? They're not the same. They both have 4 legs, they both have a tongue, they both have eyes, they both have ears. They're not the same. They're different types. Well, strings, things in quotes, and numbers are different types. So I'm going to say, make my guess number an integer. So if I put it in that function, if I put it in that helper called integer, it'll convert it to an integer. So if they're equal, print great. Now, let's see if this is correct. So let's click on check. Stop. Well, here I called this end, not stop. So it caught that for me. So I'm going to change this to end, check again, and now it's fine. Now let me save that and run it. Enter a number, 3. Nothing happened. Well, so my guess was 3, I entered that. What is the number to guess? It's 2. So it worked properly. If I had entered 2, it would have printed it. Now, let me add one more thing. If I want to do something when my question is not true? Well, then I add over here an else. Print, too bad. Let me check this. It checks fine. Stop and run. Enter a number. I guessed it correctly. Too bad. Too bad. You've just written your first program. You've just created a game. Think about the games you play on a computer. Well, this one is really simple. What is this, 11 lines and 2 of them are blanks just to make it easier to read? That's all there is to computers. Well, folks, my goal is that you're just not as afraid of computers. You understand now that a computer is just a machine that has a recipe we call a program that uses variables which are just stuff that we're storing, and you type your program into an IDE, and programs you get from other people were just created the same way we created this today. So if you think you learned something, please subscribe to the channel. Click on the bell because I'm going to be doing a lot more videos about basic technology concepts on this channel. The Dr. Vax channel teaches people how to make things using technology. So there are over 150 videos about 3D printing and woodworking and a little bit of electronics. And now there's going to be more and more computer programming. Thanks so much for watching. Let's continue to learn things together.